Many web applications require persistent storage, storage that persists beyond the web browser session, that lasts even when the user logs out, turns off their computer, and logs back in. And if we want to have persistent storage, we need to save data on the server. So far, we've only learned one way to do that, and that's to store information in files on the hard drive of the server. But most modern websites don't use that approach. Instead, they store data using databases. And so today we're going to introduce the most common language used for accessing databases, a language called SQL, or Structured Query Language. So if we store information in files, we have to deal with some big drawbacks. If the file is complex, then we have to not just read it from the disk, but we have to split it up into its constituent parts and try to parse it and understand what that data really means to find the information that we're looking for. And that can be hard, and it can also be slow. File access can also be really slow if the file is large, because it can take a long time to read off the disk, especially if we don't know the position of the data we're looking for in advance. If we're looking for something at the end of the file or at the beginning of the file, it's pretty easy to retrieve it using Python. But if we want to find something in the middle and we're not sure exactly where that is, we're going to have to read in that entire file and scan all the way through until we find it. And that can take a lot of time. Often, our web application needs to be responsive. It needs to respond quickly to the user's request for information. We can't wait for a long, slow file operation. Adding data to the end of a file or at the beginning of the file, again, is usually fast. But if we're inserting in the middle, that can also be slow and tricky to do without overwriting other information. So if we have some sort of structured record format, then files are not a great way to store that information. So instead, we use something called a database. What is a database? A database, or a database management system, it's just a program that allows us to quickly and easily store and retrieve information. And there's lots of different kinds of databases, but for a long time, sort of the king of the heap, the most important kind of database that we use is called a relational database. And a relational database is just a database that stores information in tables. So we're going to have lots of different tables of information that we can combine in different ways and we can perform queries on. And by using queries, we'll be able to answer different questions about the data. So most relational databases today support a query language called Structured Query Language, or SQL. It turns out that in the last 5 to 10 years, a new approach to storing data that works better when you have multiple servers and when data is spread across a whole bunch of different computers has become very popular. And that's sometimes called NoSQL, or not only SQL. We won't talk very much about that. But if you come to Longwood and you take my database class, we'll talk a lot about alternative approaches to storing data. So what is a relational database? Well, in a relational database, we store information in tables. And each table has columns and rows. The columns represent the different kinds of information that we might represent. And the rows represent specific pieces of information. So for example, I could have a classification table that tells me something about different animals. In particular, I could give the common name of an animal, its genus, and its species. So here I have a table that shows that the common name of the animal is wolf, and that the genus and species that go with that are Canis lupus. That the genus and species of the animal with the common name lion is Panthera leo. Similarly, I can have an anatomy table that has a list of animals, how many legs they have, and whether they have a beak or not. So for example, a seagull has 2 legs, and it does have a beak, but a lion has 4 legs and doesn't have a beak. This is maybe a little bit of a contrived example. I apologize. So what is SQL? Well, SQL is a language for describing database queries. And a query is basically just a question that we can ask about the data in a database. More formal definition here. A query is a set of criteria that we apply to data in the database to answer a question. So for example, if I had a database that contained information about baseball players, I might do a query that looked like this. I might say select the name, the batting average, and the number of home runs from the table's players and teams, where the team that the player is on is the same as the name of the team, and where that team has at least 60 wins. So we'll break that down in a minute, and you'll understand more what the different parts of that query are. But there are a lot of different database systems that allow us to use SQL to access data. One of them is called SQLite. SQLite actually stores data in a flat file. It's really just a way to do file access, but it has this nice front end that allows us to use SQL queries to access that information rather than having to parse it ourselves in Python or C or whatever language we're using. Another popular database is MySQL. MySQL is part of the LAMP stack, so it's widely deployed for doing web applications. An alternative to MySQL is PostgreSQL. This is the database system I prefer to use. I think it's a little bit faster than MySQL for most applications, and it has some really nice features that MySQL is missing. I also think it's easier to create users in Postgres than in MySQL. Microsoft, of course, has several databases, Microsoft Access, Microsoft SQL Server, and then, of course, there's if you have a really high-powered data set and needs a lot of performance, you might pay some money and use Oracle. We can access any of these systems from Python, and Python provides sort of a standard interface that will allow us to use SQL queries against any of these, and that's called DB-API version 2. So the fundamental operation of an SQL query is the select statement. And the select statement just specifies information to retrieve. So that information might come from a table of the database, or it might be the result of a computation, or maybe both. Maybe we perform a computation on some information from the database. So here's some example select statements. So I can say select, and then in single quotes the word Bob. And in SQL, all string literals have single quotes around them. So select single quote Bob, single quote will select the string Bob. So if I were to print out the results of this query, it would just print Bob. Similarly, I can do a computation. I can select 20 plus 30. The SQL database will add 20 and 30 and get 50, and it's going to print out 50. If I want to access data from a table, I could say select name from players. SQL is going to look for a table with the name players, and it's going to look for a column in that table with the value name. So it's going to try to find a name column, and it's going to print out all the names from the players table. So if I have 10 players, it'll print out 10 names. There's kind of a nice shortcut. If I want to print out all the columns of a table, I can say select star from, and then the name of the table. So I can say select star from players, and it'll print out a list containing every column and every row of that table, of the players table. I said before that I can actually do computation on the fields of a table. One of the things that I can do is find the maximum. So I can say select max, and in parentheses, this is sort of like function notation in JavaScript, I can say score from players. So it's going to look through all the scores in the players table, and it's going to print out just the largest one. We can also use the select statement to print out more than one value. So here I can say select Bob, comma George, and it'll print out Bob, George on the same row. I can do multiple computations. So I can select 30 plus 20, comma 30 minus 20, and it'll print out 50, because that's 30 plus 20, and then it'll print out the 10. I can have it go to a table, the players table, and select both the name and team columns. So it's going to go through every row of that table and throw away all the information except the name and the team. So it might say, I don't know, Michael Phelps is on Team USA, for example. I can also perform computations the same way. So I can select the maximum score and the minimum score from the players table, and it'll print out on one row the maximum, comma the minimum. Of course, most of the time I don't want to print out all the information. I'm usually just interested in some of the information. And so I can combine the select keyword with the where keyword. And the where keyword allows me to specify some criteria to use in deciding which information to print. So here I can say select the name from the players table where the number of RBIs is greater than 100. That's runs batted in baseball. So this will list all players who batted in more than 100 runs. Notice I didn't say greater than or equal to, so if you have exactly 100 runs, you're not going to get printed in this query. Similarly, I can select the batting average from the players table where the name is Jose Altuve. So it'll go through all the rows and say, is your name Jose Altuve? Is your name Jose Altuve? Is your name Jose Altuve? And if it is, then it'll print out your batting average. Otherwise, it won't print anything. By the way, Jose Altuve, I think, had the highest batting average in the American League this year, which is why I picked him. We can also do what are called joins. Basically, we can take two different tables and put them together to answer a question. So if you remember, a couple slides ago, I had these two tables, the classification table and the anatomy table. And I can put them together to get information about both. So I can say, select the genus and species name from both of these tables, from the classification table and the anatomy table, where the name is the same as the animal. So the name column is the same as the animal column, and the number of legs is 4. So what it's going to do it's going to go over to the classification table, and it's going to look at the name. It's going to say, okay, the name is wolf. And it's going to search the anatomy table and say, is there a wolf in this table? And when it doesn't find the wolf, it's going to skip to the next animal. So then it's going to go to the lion. And it's going to say, okay, the lion is Panthera leo. Is it in the anatomy table? And it's going to go look at the animal column, and it's going to say, okay, seagull isn't the same as lion. Okay, but lion is. So it's going to take the lion Panthera leo row from the classification table and the lion for false row from the anatomy table and put them together. And then it's going to give us just the genus and species. So it's going to check if the number of legs is 4, and since it is, it's going to print out Panthera leo. That was kind of complicated, but I hope you followed it. Basically, it's checking both conditions. It has the name in the classification table must be the same as the name in the anatomy table, the animal in the anatomy table, and the number of legs must be 4. If both of those criteria are true, it prints out the genus and the species. So if we want to be able to perform these queries, we first have to be able to put data into the database, and that means we need to have some place to put the data. So we can actually create tables in the database with the create table command. That looks like this. So I could say create table anatomy, that's the name of the table. And then in parentheses, I tell it that the values or the fields are animal, which is a text field, legs, which is an integer, and tail, which is a Boolean, a true or false value. Different databases support different types of data. So some common types are text, integer, Boolean. There's also varchar, and in parentheses you put a number. That's sort of like text, except it has a maximum length. So I could say varchar of 20, and that would only accept strings of length 20 or less. Using varchar has some performance advantages. It makes your database a little bit faster than using text. Numeric of digits, comma decimals will let you store floating point values. And also, a lot of databases support a date, a time, and a timestamp type. Once you've created a table, you can insert data using the insert into keyword. So I could say, for example, insert into anatomy. And then I tell it which columns I'm going to specify. I'm going to specify first the animal, then the number of legs, and then the beak with these values, wolf for false. The order matters here. The order inside the first set of parentheses has to match the order in the second set of parentheses. So for example, if I said 4, comma, wolf, comma, false, this wouldn't work because it would think that 4 was the name of the animal and wolf was the number of legs. And it won't like that because wolf isn't an integer. Similarly, I could insert into the classification table the values name and genus and species. And the values would be seagull, laris, and canis. I think if I got these switched around, it wouldn't complain because it wouldn't know the difference. But it wouldn't work correctly either because it would put them in the wrong column. So it's important to preserve the correct order. You can also modify existing data. If you've already inserted data into the database but you want to change it, maybe you typed it in wrong and you want to fix it, or maybe the information's changed. Maybe somebody's moved and you want to update their address. You can do that with the update command. So for example, here I can say update anatomy, set legs equals 8 where name equals spider. And if I had a row of my table that said the spider has, 6 legs and does not have a beak, now that 6 legs would change to the correct fact, which is that the number of legs on a spider is 8. So in summary, SQL is a query language that's used with relational databases. SQL queries typically start with the keyword select and a list of columns to print, but we can combine them with a where clause to select specific rows of a table. Tables can be created using the create table command, and we can add data with the insert into keyword and the update keyword. Next time we'll talk about how to use this from Python so that we can actually create databases and store information in them. And then we'll talk more about how to develop sophisticated web applications. Have a great week.